Okay, we're looking at measuring the rotor, and most manufacturers will print on the rotor somewhere what the minimum thickness is. Anything below that will cause braking problems. So I found it on the edge of the rotor. I don't know if you can see it real good, but it says MINTHK, and then it has 28 mm. And so that's 28 millimeters. So if the rotor is thinner than 28 millimeters, it has to be replaced because it wore down too thin and it doesn't effectively remove the heat from the brake pads when you're braking, and that can be dangerous. So the tool we're going to use actually measures in inches. So what we have to do is convert the 28 millimeters to inches, and the way you can do that is there's 25.4 millimeters in 1 inch. So because we have 28 as our minimum thickness, if I divide 25.4 into 28, I get 1.102 inches. So that will allow me to use a tool that measures in inches. So what I'm going to use is this tool here. This is actually called a micrometer. Now we're going to get into more detail on how to use one of these tools. So we're going to have a whole lesson on that and some practice. But what I'm going to do is I'm going to put it around the outside of the rotor, and then I'm going to tighten it, and then I'll show you what I can read on there. So as I tighten this tool up around the rotor, I can lock it in place, pull this off the rotor. Let's see, or I'll just read it on the rotor. Sometimes there's a lip on the rotor. This one has a lip on it. There's the numbers on the tool. Now this is what they call a 1 to 2 inch micrometer. If you look here, it has a range. It says 1 to 2 inch, and below that it says it can read in 10,000ths of an inch. So 1 to 2 inches, its range. That means on this scale here, the 0 on this scale where my finger's pointing is exactly 1 inch. So I'm reading over 1 inch. This one that you see here represents 1/10 or 0.1 inches. So it's reading 1.1. And then if you look real close, you'll see little lines after the 1. I see 1, 2, 3 small lines after the 1. Each one of those little lines represents 25 thousandths of an inch. If I have 3 of them, that means it's 75 thousandths. So this is reading 1 inch plus 0.1 plus 0.075. And this part that spins, it's not quite past the 0 here. It's almost at the 1. We're going to just call it 0 because it didn't get to the 1. So this is reading 1.175 right now. So I'm just going to write that down on our piece of paper here, 1.175. Okay, so this is my measured reading, and this is the minimum specification. So if you notice here, my measured reading is larger than my minimum. That means the rotor is good. If I want to figure out how much it is good, I can take the 1.175, right, and subtract the 1.102 from that, and I have 370. So basically what it's saying is I have 73 thousandths material over and above the minimum that's still on this rotor. That means if I had to machine the rotor and take off some metal to make this nice and smooth again, I could take off as much as 70, let's say about 50 thousandths. You always want to leave a little for wear, so let's call it about 50 thousandths. So I could take like 20 thousandths of material off each side of this rotor, and I could still use it. So it looks like it still has enough for maybe one machining, which we're going to show you in another class, another video. All right, so at this point, I'm going to be able to use my rotor again. I'm going to mount it back on the hub. You should, if you're going to put a new rotor on, you might want to clean up this rust that you see on the outer part of your hub with like sandpaper or a spinning tool that actually has like a little pad on it. we're going to put this on. I'm going to be serving some of this again, so I'll just put this on for now. Line up all the lug nuts or all the studs. Okay, so first thing it has to go back on is our mounting bracket for our caliper. And again, we're going to put this on the back of the rotor, right around the rotor.